So let's see second problem. For the given circuit, you have to find, as you can see the question, they've asked you to find only R equivalent. They have not told whether you have to use delta to star or star to delta, or it's only series parallel. You have to reduce using series parallel star delta. So how do we start? Check if there are any elements in series. Check if not. If you find any elements in series, that's your step 1, convert it. Then your step 2, you have to again start from scratch. Let's check for any elements in series. If they're not, then check for parallel. If they're not in parallel, then check for star delta. But here I'm giving you the solution that none of the elements are in series and parallel. So we have to convert using delta to star or star to delta. So I'm rewriting the circuit so it will be easy for you to understand. You need not do this once you've understood, right? So I'm rewriting this, both are same. Now I'm converting this delta to star. I repeat, it's left to you. So let us first debate which all the star elements. So 10, 10 and 10. These three are in star, right? And then 10, 10 and 10. They are in star, right? I've already shown that these 3 10 are in delta, and similarly these 3 are in delta. So you can choose any one to transform. I'm using these 3 for delta to star, right? So whenever you're converting delta to star, you'll have 4 common points, right? These are 4 common points. So I'll arbitrarily name them as A, B and C, and the formula for A is 10 into 10 by 10 plus 10 plus 10, and I hope you're aware that B and C also would be same, because B is also connected between 10, and since the numbers are same, it's easy for solution, right? So either A or B or C, the value of its star equivalent is same. So remember, we have counted delta as 10, 10 and 10. These 3 tends to the equivalent star A, B and C, right? Now what do? We remove those delta and retain those star. I repeat, you remove those delta and retain those star. That is, you'll be removing these 3 elements and retaining these 3 elements, right? And please remember, never miss the ends A and B at any cost. So now you can see this 10 will go, but what about this B? So this B is connected to this C here, so you can remove this to a line and shift your B point here, right? I hope it's clear, right? Next, what do? As I told, after each step, you have to again start from scratch. What is the first step? Analyze for series, then parallel, and then star and delta. Now step 2, this we got from step 1. We've converted the delta to star, analyze for series and parallel. So these 2 elements are in series. Any other elements in series? Pause and think before I say the solution, right? Yes, these 2 are also in series. So when we add them up, the solution is 40 by 3 and 40 by 3. That's your step 2. I'll not be writing a step 3 separate, but this is actually your step 3. So what do you do in step 3? In step 3, again you start from scratch, analyze for series, but it is not there. Then you analyze for parallel. So what do you think? Are there any elements in parallel? Yes, we have these 2 elements in parallel. So how do we say that these 2 are in parallel? So we can say that these 2 are parallel because of the 2 ends. 40 by 3, one end is at A, other end is at this junction. And this 40 by 3, one end is at A and other end is at this junction. So these 2 are the common ends for these 2 elements, and thus we can say that they are parallel, right? So I hope you know the formula. 40 by 3 into 40 by 3 divided by 40 by 3 plus 40 by 3. I'm not showing you the formulas here because we've already done that in the previous videos, and the answer is 40 by 6. And needless to say, I hope you know that these 2 are in parallel or series. They are in series, and the answer is 10 ohms, right? This is your second problem. So let's see one more problem. So you can see each problem is, I'm just trying to increase its complexity. So here they've asked us to reduce the circuit, and again you can see they've not told us either you have to do it in series, you have to do it in parallel, you have to do from star to delta or delta to star. It's up to you, right? So by practice you will know how to use, which all method to use. But just keep this three things in mind. Start in each step, analyze for series, analyze for parallel, if they're not in series and parallel, and then you can do it for star delta transformation or delta to star transformation. Now here you have a small assignment for today. B and C, to find the equivalent B and C, and remember the answer for whatever we solve, the answer for A and B and B and C, whether they are same or different, we have to see, right? You have to solve and see. This is for you to solve, right? So A and B. So what I'll be doing? So this is your star, right? So let us understand again which all are star and delta. So this is your star, right? And the outer is your delta. This inner is again in your delta. These three are in delta. These three are in delta. So you can use out of these combinations, you can use any element for star delta. It's my wish that I'll be using this star to delta. It is easier, right? You'll understand. Once you start somewhere else, you can see the process will be, the number of steps involved will be more, right? It only comes by practice. So convert this star to delta. So when you're using star to delta, there are the three ends, that is A, B, C, right? But they've asked us to find only across A, B. So neglect C, as you see here, we have neglected C because you will go wrong. Take this ends A and B for each steps, right? You can see we are using these two ends here. So take these two at the end, and C we have neglected, right? So now between A, B we have one element, between B and other end we have one element. Similarly, between the other end and A we have one more element. Now we call them respectively A, B and C, and we know the formulas, right? So when you solve, you'll be getting as 18, 9 and 13.5. I'll substitute those formulas. What do you do then? Once you've converted star to delta, what you have to remove, what you have to retain. If converted star to delta, remove star, retain delta, right? This is your reduced circuit. Then what do we do? Check if any elements are in series and parallel. I repeat, check if any elements are in series and parallel, right? So these two elements are in parallel, these two elements are in parallel. 13.5 and 1.5 are also in parallel. None of the elements are in series, these two are in parallel. That's your next step, right? So when you convert them respectively, the answers are for 18 and 9, the solution is 18 into 9 by 18 plus 9, and vice versa. Similarly for the other two elements, this is its solution. Then what do you do? Again you will check if you have reduced, right? Again you have to start from the scratch. Check if they are in series, then check if they are in parallel, right? So now what do you think? If there are any elements in series, right? These two elements are in series, right? You can see just like your train coach, right? There's no diversion point here, right? These two are in series, right? And here is the solution. Again, what do you do? For the next step, check if they are in series, right? And the answer is no, none of the elements are in series. Then check if they are in parallel. Yes, these two are in parallel. How? Between A and B, right? 6 and 2.25 are in parallel. They share common boundaries. So 2.25 has two ends. One is connected to B and the other end is connected to A. Thus they are in parallel, and your answer is 1.636 ohms.